Here we have a couple different objects that are going to race down a ramp, a height h, and angle theta, and we want to know what are their final places in the race. This is just a conservation of energy problem. So the types of energies that can be in this problem are the gravitational potential energy, which is mgh, the kinetic energy due to rotation, which is 1/2 I omega squared, and the kinetic energy of translation, which is 1/2 mv squared. Those are the three different energies that we have. So let's start with our initial. Initially, they're all at rest. So Kr equals Kt equals 0, and the gravitational potential is 1/2, or is mgh. We're not given any numbers here, but all of these things have the same mass and the same radius r. So we're going to do everything in terms of variables. So then final, gravitational potential will be 0, but then Kr will be 1/2 I omega squared, and Kt will be 1/2 mv squared. So each one of these things has a different I, but the omegas are all the same. So from our rolling condition, we know that V equals R omega. So omega is V over R. So our rotational kinetic energy becomes 1/2 I V squared over R squared, because we're just plugging in what omega is. So this is our rolling condition. So our total final energy is 1/2 I V squared over R squared plus 1/2 mv squared. So this is 1/2 I for R squared plus mv squared. So I just factored out all of the factors that are related to the object. So that means our initial energy is mgh. So using the conservation of energy, EI equals EF, so mgh is 1/2 I for R squared plus mv squared. So to determine what object wins, we have to look at our velocity. So let's solve this for velocity. 2mgh equals I over R squared plus m, quantity times v squared, and then divide by what's in the parentheses. So we take the square root, v, the square root of 2mgh over I for R squared plus m. This looks very complicated, but it's because we haven't plugged in I. Each object has a different I. So let's go through our objects in our race. So a particle has a moment of inertia equal to 0. So that means that our velocity is just the square root of 2mgh over 0 plus m. So this is square root of 2mgh over m, which is the square root of 2gh, which we've seen before. Next, we have, let's go back up to our picture, a sphere. So a sphere, if we look at our table in the notes for our moments of inertia, a solid sphere has a moment of inertia of 2/5 mr squared. So let's plug that in to our velocity equation. Square root of 2mgh over I 2/5. Let's make that more legible. 2/5 mr squared over r squared plus m. All of this is under our square root. So our numerator is going to stay the same, 2mgh. Our denominator, these r's will cancel, so we'll get 2/5 m plus m. And that is square root 2mgh. Our numerator stays the same, but 2/5 plus 1 is 7/5 m. So now our m's cancel, and we get square root of gh, and then 2 divided by 7. This is divided by 5 is just 5 times 2, 7ths. Next, we go back to our picture. Oops. We have cylinder and hoop to go. So, zoom in a little bit. Let's go over here and do cylinder. So a cylinder, we go back to our moment of inertia sheet. Cylinder or disk about center is 1/2 mr squared. So back to our velocity equation, square root of 2mgh over I, 1/2 mr squared over r squared plus m. Two mgh, our r's will cancel, and we'll get 1/2 m plus m, which is square root 2mgh over 3/2 m. The m's will now cancel, and we get 4/3 gh. And the last thing we have to do is the hoop. The hoop has a moment of inertia of mr squared. So the velocity is the square root 2mgh over I mr squared over r squared plus m. So that gives us our r squareds cancel. Square root of 2mgh over m plus m, which is square root of 2mgh over 2m. The 2's and the m's cancel, and we get the square root of gh. So we have 5 velocities now. So let's undo. Let's put them all together to look at. We have the particle, the velocity is square root of 2gh. The sphere, the velocity is square root 10/7 gh. The cylinder, velocity of 4/3 gh. And the hoop, velocity square root GH. So 2 is greater than 10/7 and is greater than 4/3 and is greater than 1. So the particle is going to get first place because it has the highest velocity. Second place with 10/7 is the sphere. Third is the cylinder with 4/3, and hoop is last.